Learn how to draw the decision tree for a given Boolean function. So the Boolean functions are those, they have two outcomes, that is yes or no. That is, we also refer it as that is the true as yes and then false as no. So first let us understand for the different Boolean operations how to draw the decision tree. First we go with the consideration, that is AND operation. That is we are taking the two variables, that is A then and B. Then how to draw the decision tree for this? First we have to take the variable A. So you can observe here A. So every variable, there are two outcomes are there. That is, one is true and then another one is false. So we are writing the two branches here, that is true and then false. And then next what we have to do. So now whenever there is a AND condition, so we have to observe here only when A is true, B is true, the result will be true, that is yes. So in any one cases, for example, A is false, B is false, the decision is no. Then A is true, B is false, decision is no. When A is false, B is true, decision is no. Right? So in the same way, only when A and B are also false, then the decision is no. Only when A and B both are true, the decision is yes. So that is why, so when A is true, so we are adding another variable B as the next node under the true. So now we can see here again we have the two values are there, that is true and then false. So now when A is true, B is true, the decision is yes. So when A is true, B is false, decision is no. And then in A is false, the decision is no. Similarly, we can go with another example to learn more about this. So we can observe here A or B. So now in the A or B, so there are considerations like when this condition become false, so the decision is no. So when A is false, and then B is false, then only the decision is no. Then all the other cases, when A is true, B is false, or when A is false, B is true, and then when A is true, B is true. In all the cases, the decision is yes. Only when A is false, B is false, decision is false. So we are writing the first variable A and with the two outcomes, that is true and false. And then when A is true, so we know 100% when this is true, the decision is true. Only when A is false, we have to check about B. So we are adding this side. So when B is true, so we can observe here when A is false, then B is true. The outcome is yes. And then when A is false, B is false, outcome is no. Similarly, negation of A and B. So negation of A, so you can observe here. So here we are going to take the in a different way. So you can observe here negation of A means that is usually we have to take true as yes and false as no. So here when there is a negation, we have to take in a reverse direction. That is for A, true is no, because since it is a negation A, and then here AND condition is there. So then A is false, so we are adding the B, because we have to verify the B that is related to the what when A is false. So now we have taken B, and then B has two outcome, that is again true and false. So when A is false, B is true, then only the decision is yes. And then when in the cases like A is false, B is false, decision is no. So only when A is false, B is true, the decision is yes. So related to this, let us have one more example. That is A and negation of B. Exact the reverse, that is A and negation of B here. That is we are writing A, and then we are considering when A is true, then only we can check for the true condition with this. So we can observe here true, but here it is negation of B. So we are checking for the false. Then when B is false, A is true, then only the outcome is yes. So when A is true, B is true. Since it is a negation of B, so the decision is no. And so when A is false, obviously we go to the no decision. Similarly, we are go with the A or B and C. So what is A or B and C? It indicates, so first we take the variable A, it has two outcomes, that is true and false. So when A is true, so we are not worried about this side. So we go with the what? A is true, so the decision is true. So next we observe that when this particular group, that is we can say this, when this is false, so then we worried about the next consideration. So now what we are going to do, so when this is true, the decision is true. So when this is false, what happens? So now when it is under false, so we have added the node B, and then we are checking the outcome. So when B is true, when B is true, so since C is there, so we also check when B is true, C is true, because B and C, so then only the decision is yes. So you can observe here when B is true. So we have added node C here. So when B is true, C is true, then only the decision will be yes. When B is true and then C is false, the decision is no. And similarly, when B is false, the decision is no. Similarly, this is for A or B and C. Here it is A and B or C. So you can observe here, this is A. That is, we have taken the two, that is the branches, that is true and false here, two outcomes. And then here we have to observe the condition. Since A is true, so then if this entire thing has to be true, then this has to be true. So now we are checking for the true condition. So you can see B or C. So first we have added under the node B. So sorry, under the node A, true condition. So node B. So then we are checking when B is, you can see A is true, then B is true. So we have taken this decision as yes. That is in the B or C condition also. When B is true, the entire result is true. So like that. Similarly, when B is false, so we are verifying this C. So C is what? True. When C is B is false, C is true. So you can observe here. So even though it is false, when C is true, the outcome is yes. So when B is false, C is false. So we can see B is false, C is false. The decision is no. Similarly, we have to write one more operation, that is AND operation, OR operation, and for XOR operation. So let us understand in a very clear way, A XOR B. So we can observe here. So this we are going to split and write in this way. That is A and negation of B, or negation of A and B. So now what we have to do, we have to write the tree based on the conditions like this. That is A and negation of B. So we have already written A and negation of B. So the same thing. So A and negation of B, you can see here A and negation of B. So we can see under the node B we have taken here. So when A is true, when A is true, so then B is false, then only the decision is yes. And then when A is true, B is true, so we can say the decision is no. So because since it is a OR operation, if this is true, then the overall results will be true. Then no need to check this. So now this is why we have written under the false. So we have added one more time, because since it is XOR B, so B, and again we have written two outcomes, that is true and false. When A is false, B is true. So when this entire thing is false and this is true, so then the decision will be yes. So when A is false, you can see here when A is false, B is false, the decision is no. Similarly, B XOR E. So B XOR A, so we have written in the reverse way, that is B XOR A. So you can see we have written again, expanded this, that is B and negation of A, or negation of B and A. So we have written node B, then the two outcomes, that is true and false, and then now we have to write it for the variable A. So we have written A. So when B is true, B is true, A is true. So you can see the decision will be no. Only when the decision will be yes. So when B is true, when B is true, A is false. Only in the XOR decision means whenever there is a true false, the decision will be yes. So whenever you have both as true, and you can also see at this side, when both are false, the decision will be no. When B is true, you can see here. And one more thing here, we have to observe, since it is a OR operation here, So if any B is false, you can say B is false, but A is true. You can see here B is false, A is true. The decision is yes. Similarly, B is true, A is false, decision is yes. When B is true, A is true, decision is no. Similarly, when B is false, A is false, decision is no. So this is what the XOR operations, that is how to write a decision tree for the Boolean function. Thank you.